This is somewhere no human being was ever meant to go. Deep in the foothills of the Himalayas, temperatures near Risi vary in the extremes, dropping from 50 degrees Celsius all the way down to freezing. Everywhere you look, jagged cliff faces create these deep, dangerous canyons. You can imagine the challenge faced by crews attempting to build a record-breaking bridge here. To access civilization, you have to trek the dusty tracks by foot or take a boat journey along the river. Simply getting to the Chenab Bridge site was an enormous undertaking, let alone manoeuvring the 30,000 tons of steel necessary to build it. No motorways, no nearby factories, and not a flat, stable surface in sight. This is construction in one of Mother Nature's most unforgiving environments. It might sound a bit cliché, but sometimes clichés do ring true. Constructing Chenab Bridge should have been impossible. From searing temperatures to dangerous ice and snow, working conditions really don't come much tougher than this.
And it's not just the crews who suffer. When it's exposed to extreme temperatures, steel can expand and contract, making it really difficult to manipulate and accurately line up. But the truth is, while crews are battling the snow and the sun, there's an even bigger challenge looming, and that is the wind. You see, this canyon can experience gusts of up to 165 miles an hour.
Now, that's unbelievably dangerous for people working hundreds of meters up in the mountains as it is, let alone when you consider the fact they're maneuvering thousands of tons of steel into place. And even if the weather decides to take it easy on you from above, there's no guarantee an earthquake won't shake the ground to its core. Any one of these factors in their own right could have put a stop to the notion of building a canyon-crossing bridge in this location. And still, they pale in comparison to the main challenge of Chenab Bridge, actually getting to the construction site.
Well, when we first started the project, we were invited to go up, and donkeys were provided to help us get up the stream.
David McKenzie is the Senior Technical Director for COVI and has been involved with the project since 2004.
The first trip on the way out, we took a boat on the way out because it was quicker by boat down the river than it was to try and negotiate these tortuous mountain paths.
Okay, so this is why Chenab Bridge is being constructed in the first place. Imagine you're in Jammu and you want to get over to Kashmir Valley. They're separated by mountains and connected by one main artery, National Highway 44, which is regularly blocked by snow. And that's where the Chenab Bridge comes in. It's just one impressive section of India's new 169-mile all-weather rail line cuts quite literally through the mountains. And as if the weather conditions for this construction team weren't challenging enough, not everyone supports this new route. Kashmir is an area of high political tension, and it's one of the most militarized zones in the world, divided between India and Pakistan.
Both claim territory in the region and administer different parts of it.
While India says its new all-weather rail line will give the area an economic boost and improve travel connections, opponents claim it's being used as a way of exerting more control over the region.
But despite these concerns, construction of the line has ploughed on. All in all, this thing features an incredible 943 bridges and 36 tunnels, one of which is 7 miles long. And apparently, all in, reports suggest that it's going to cost a mere $5 billion. Now, for context on that, in New York, $5 billion would get you 2 miles of 2nd Avenue subway. Now, when seemingly every project we look at costs millions, if not billions of dollars, it's easy to lose perspective over the scale of money that's being talked about. $2 billion on a skyscraper here, $10 billion on a railway over there, and sometimes these projects can run into the trillions. Balancing those checkbooks would bring most of us out in a cold sweat. In fact, I feel a bit sick just thinking about it. But if you want to say goodbye to headaches, then say hello to Odoo, an all-in-one business management platform providing more than 45 apps to help you stay on top of business. Odoo's accounting app, designed with accessibility at heart, not only offers peace of mind that your money is being processed properly, it also cuts the faff. You can create unlimited invoices in seconds, then by syncing your bank accounts, Odoo monitors payments and even sends automatic follow-ups to late payers. Smart AI recognizes supplier invoice data, further slashing your manual tasks. And you even get access to intuitive dashboards to make tracking your financial data easier than ever. It doesn't matter where you are either. The app caters to your local tax regulations, helping to keep you compliant and law-abiding. But here's the catch. There isn't one. Odoo will let you try out their accounting app for free, and with unlimited hosting and support, you can't really go wrong. To try your first Odoo app for free, head to the link in the description. It massively helps us out here at the B1M when you guys take the time to go and check out our video sponsors, so please do that at the end of the video. Now, from managing your money to managing a mega bridge in the Himalayas, let's get back to Chenab.
This is the Chenab Bridge worksite in 2020, and on either side of the canyon you'll notice these fabrication workshops. You wouldn't usually find them on modern construction sites. Usually on a project this big, key components would be prefabricated in factories far away and then manoeuvred to site, but as we mentioned, that wasn't an option here.
So right about now, you're probably asking yourself, well, if this project's so hard to get to, then how the hell did they get 30,000 tons of steel up there? And the answer is pretty extraordinary. Just to make this extraordinary location even remotely accessible, they put in 26 kilometers worth of roads just for this project. But if you're prone to travel sickness, I'd advise you look away now, because these roads were built in some pretty precarious locations, clinging to the side of mountains and going along some serious cliff edges.
The most efficient way of transporting steel is in flat plate. Think of it as an IKEA catalogue. Everything came to site, flat packed, and indeed all the cutting and all the drilling was done on site.
And don't expect things to get much easier when you've reached the site. Once you finally have all the materials on location, then comes the small issue of building the bridge, hundreds of meters above the ground over a massive canyon. The topography here is nothing short of a nightmare. A jagged rocky canyon split by a river makes for some beautiful views, but an incredibly tricky engineering job. As I mentioned earlier, one of the biggest factors is the wind, thanks to a phenomenon known as the Venturi effect. That's when a narrow passage like a canyon effectively becomes a giant funnel. As wind passes through, its pressure drops as its speed increases, creating powerful and chaotic patterns. And that's all before we've discussed the terrain. In geological terms, the Himalayas are very young, and they're still moving. The range was forced up by the Indian and Eurasian plates driving into each other, creating a heavily twisted landscape. The rock along its canyons is fractured and friable.
Now, by nature, a canyon is kind of a V-shape, and the problem is if you fix a tower to one side of that V-shape, particularly one side that's got very unstable rock conditions, there's a tendency for that tower to want to slide down the valley and slip, which is why the Chenab Bridge is an arch design. It starts from either end and both sides meet in the middle, creating a locked formation like this. As they meet in the middle, the two sides push against each other and force their weight down their legs into the sides of the mountain.
So I mentioned that a canyon acts a bit like a wind funnel, creating these powerful gust patterns. Usually you'd create a model of the structure, in this case a bridge, and then put a scaled down version of it to the test in a wind tunnel. And while that was done here with about a 1 to 50 scale model, the unique topography called for some more drastic research.
What we then did was some localized tests, both physical tests, but also computational tests. So we modeled the environment around it, all the hills, the valleys, so then we could actually then calculate what are the accelerated flows locally, because of course they push up the net wind speed. So there's an acceleration of 20%. Your maximum wind speed of, say, 50 meters per second is now 60, 70 meters per second. So you've got to take those things into account, and that's what the important thing was done here, was to do those particular studies, because they were very important to the design.
Now, the ability to stabilise this bridge with an incredibly strong arch is crucial, but it's stretching over a canyon hundreds of metres above the river down below. To actually build it, crews had to first construct a cable crane. It's a bit like an aerial trapeze or a monorail made of cables. Towers are constructed on either side of the canyon and a cable connects them. Pieces of steel for the arch are winched across on the cable crane into their correct location. Each side of the arch is then built from the bottom upwards, held back by cables that are locked into the rock to stop it all from falling nearly 400 metres down into the river below. And once complete, hey presto, you've got an arch. Now, the arch is the key component supporting the entire bridge structure, but obviously it's not fit for a train to go across it just yet. Once the supporting towers are erected, that's when the top deck comes into play, and it's a pretty heavy component.
The top deck is a flat piece of the bridge that's constructed in sections. Basically, working from each side of the canyon, a piece of the bridge deck is laid, then another piece is put in behind it, then another piece behind that, and so on and so on. And gradually the bridge deck is pushed out across the canyon until the two sides meet in the middle. It's what's known as a launch methodology.
What's cool is that this structure is so big that the scale of earthquakes generally experienced here shouldn't be too much of an issue for it in comparison. But that's more than just a stroke of luck. Engineers here were well aware this area faces some pretty intense seismic activity.
When you get bridges of this size, curiously, if you imagine the ground is shaking, but in proportion to the size and span of the structure, that shaking is actually quite small. If you halve the span, relatively that shaking is twice as much, because the shaking is a fixed amount, so the ground shakes by, let's say, plus or minus 10 centimeters. But if the bridge is 100 meters long, if you double it to 200 meters long, of course, then the relative effect diminishes. So actually the seismic is less of an impact on the main arch, but it does affect all the rest of the approach structures.
It goes without saying, the stability of the top deck is crucial. The safety of trains has to be central to the project's construction. And one of the key environmental threats to the bridge's stability is one that is experienced around the world, although maybe less so in the UK. The sunshine. If you were paying attention, you'll remember I said right at the start of this video that temperatures at Chenab Bridge vary from freezing all the way up to a scorching 50 degrees Celsius, and that impacts the steel that the bridge arch is made of. The big problem with a canyon is that the sun can only shine on sections of the bridge at any one time, meaning it'll need to operate at different temperatures.
Now, as the bridge arch warms and cools, it bends and flexes, which isn't great for moving trains. But to get around that, the rails have been pre-stressed. They've been pulled really tight for stability. They're also allowed to move freely of their fixings on the bridge. So the fixings that are on the bridge have the rails sitting in them, but they're not actually attached. So the rails can move back and forth as the bridge moves over time.
Designed by the WSP team in Finland, the arch and its towers loom over Chenab River. The rock and steel blend in with the mountainous backdrop, and in doing so, offer some of the best train passenger views on the planet.
Yeah, very fortunate to work on a number of very exciting structures in my lifetime. But this one holds particular passion for me because it's, having seen it from ground up over a 20-year period, and having seen where it's being built, quality with which it's been built as well. It's incredible how well it's been fabricated in the yard. It really is an incredible piece of engineering, and I think just looking at the pictures as I am on my screen in front of me, it really does tug at the heartstrings as being the challenge I am most interested in, and the proof is I have it on my laptop every day to look at it.
The line was inaugurated in summer last year as India begins its next chapter of connectivity. And while Chenab Bridge is just one part of a number of rail projects across this country, it might be the most impressive.
To create this bridge, construction teams had to build where no one else has built before. And yet, through determination and innovation, they've made it a reality.
More than 20 years after construction first began, following delays and complications, boat journeys and trekking on donkeys, cable cranes, and miles of purpose-built roads, construction crews found a way.
The Chenab Bridge is a perfect example of the hardships faced by construction teams working in some of our planet's most extraordinary environments. The enormous effort invested to create structures like this paves the way for future generations and proves once again what the amazing construction industry is capable of. This video was sponsored by Odoo. I want to say a huge thank you to them for their support. Please do click the link, go and find out more about Odoo and get involved in what is a fantastic platform. And as always guys, if you enjoyed this video and you want to get more from the definitive video channel for construction, hit that subscribe button.